friends. You can invite your friends, relatives, and so on, all those who could be interested through the link. The link has been posted in the chat. Or you could, or if those who already in the WhatsApp groups, it could be there as well. You could get it and invite other friends because we are already underway. So we shall go on and start with the first question. Yeah, and that is our first question. It says that given that the logarithm of x to the base 3 is equals to p and the logarithm of x to the base 18 is equals to q, show that the logarithm of 3 to the base 6 is q divided by p minus q. So we shall start by, of course, stating what is given to us. And we all know that these are logarithms, so we cannot escape the laws of logarithms. And here we are going to apply simply this law. Where the logarithm of b to the base a can be written as well by saying 1 over logarithm of a to the base b, which is equals to c. So this is what we are going to apply basically all through. And of course, the standard ones of addition and subtraction. So I'll start by stating what is given unto us. We have log x to the base 3 is equals to p, and log x to the base 18 is equals to q. So what we are looking for is how we can manipulate this, because we can see it is the most interesting one. So what we shall do, we shall start by manipulating this in such a way that we shall use this law that is already stated up here. And we shall have 1 over log of 18 to the base x is equals to q, which could mean log of 18 to the base x is equals to 1 over q. So 18 can as well be written as 6 divided by 3. I'm doing this because we have a certain log of x to the base 3. So we have that, sorry, can be written as 6 by 3. Six times 3 equals to 1 over q. So that gives us log of x, log of 6 to the base x is equals to, plus log of 3 to the base x is equals to 1 over q. And still, we can have this as the log of 3 to the base x is equals to 1 over p. So I'm going to use this right here. And that will give us log of 6 to the base x is equals to 1 over q minus 1 over p, which is the same as saying p minus q over pq. Now we can manipulate this as well to have using another law of logarithms. What I'm looking for is how I can get this. So we can as well say log of 3, log of 6 to the base 3 is equals over the log of x to the base of 3 is equal to p minus q over pq. Yes, and log of 3 log of x to the base 3 is equals to p. So that gives us log of 6 to the base 3 over p is equals to p minus q over pq. So these two will have to cancel out, and we'll remain with log of 6 to the base 3 being equal to p minus q over q. That in turn can be written as 1 over log of 3 to the base 6 is equals to p minus q over q. And of course, we have to make log of 3 to the base 6 a subject. And that implies that we'll have our final solution as log of 6 to the base 3 as the reciprocal of whatever was on the right-hand side. And with that, we have been able to solve question 1. I don't know if there are any questions regarding what has just been done. You could raise a hand or you could type it in the chat. Okay, it looks like we are all good. Yes, that has been number 1. I would like to invite yes, Firdaus Shakira, you can ask your question.
I've not understood this part where we are having 1 over what? This part of log 3x is equal to p. Then we are having log of x 3 is equal to 1 over p. Then this other side, we are having the opposite. We are having 1 over log of x 18 is equal to q. Can we make this other side the same as this side by saying that 1 over what? 1 over log of x 3 is equal to p. Can it
Yes.
also work?
Yes, we can. And I just skipped that step, but that's what it is, essentially.
Thank you.
Okay, welcome. Other than that, I think there is no other question. Yes, I would like to invite the next presenter.
Yeah, good morning, everyone. I will be sharing my screen shortly. Yeah. All right, so our second question was from trigonometry. And according to most people, I think this is one of the easiest topics in paper one. I believe it's correct. It's true. Yeah, so the question says solve the equation tan 4 beta plus tan 2 beta is equal to 0 for angles within that range. Yeah, so you must know which trig property we are going to use for that question. Yeah, so we know that for a double angle, for example, tan of 2a, you can write it as 2 tan a out of 1 minus tan squared a. So that is the property we are going to use here. Yeah, because we have 4 beta and 2 beta. 2 beta is twice. 2 beta is half of 4 beta. So we can apply that property here to help us solve that equation. If you don't know it in your head, you can always get it from the logbook. But I believe we all know it. So substituting for tan 4 beta, we shall have 2 tan 2 beta out of 1 minus tan squared 2 beta plus tan 2 beta is equal to 0. So I can multiply through by this denominator that I have here, the 1 minus tan squared 2 beta, and I'll have 2 tan 2 beta plus tan 2 beta times 1 minus tan squared 2 beta is equal to 0. So when I open these brackets, I'll have 2 tan 2 beta plus tan 2 beta minus tan cubed 2 beta being equal to 0. Yeah, tan 2 beta times tan squared 2 beta will give us a tan cubed 2 beta. Yeah. So when I add tan 2 beta to 2 tan 2 beta, I'll get 3 tan 2 beta. So I have 3 tan of 2 beta minus tan cubed beta is equal to 0. I can factor out tan 2 beta since it's a common term. So I'll have tan 2 beta into 3 minus tan squared 2 beta is equal to 0. Yeah, so at that step I can apply the 0 property because we're multiplying 2 terms and getting 0 as our product. So we can have either tan 2 beta being equal to 0 or 3 minus tan squared 2 beta being equal to 0. Yeah, so if I'm to look at tan 2 beta being equal to 0, I'll have 2 beta being equal to tan inverse of 0. So you can get your calc and you try computing the tan inverse of 0. Yeah, now our ratio is positive, which means that we are interested in angles where tan is in angles that lie in the quadrant where tan is what? Is positive. And those angles are in the first and the third quadrant. If I'm to draw a simple quadrant here. So we want angles in that quadrant, the acute angle in that quadrant, and this angle in this quadrant. So angles in the first quadrant, just get the ratio we get when you compute the tan inverse of the positive value you have, a positive ratio, the angle you get. Then the angles in the third quadrant are got by adding that angle, acute angle you got, plus 180 degrees. Yeah. So when I get tan inverse of 0, it gives me 0 as the answer. I hope you have your calc and it's in degrees. Please always remember to check. If you left it in radians previously, you have to change degrees since you're getting angles, degrees. So tan inverse of 0 is 0. So we shall have 2 beta being equal to 0 degrees. Then when I get 0 degrees and add 180 to it, because I want to get the angle in the third quadrant, I'll get 180 degrees. Yes, but I can also consider getting angles when I move around a whole revolution. For example, if I moved around and came back to that quadrant having the 0 angle, that's like getting 0 degrees and adding 360 to it. So I'll have 360 qualifying. And then I get 360 and add it to the 180, I'll have 540 degrees. I'm trying to get as many angles as possible because I'm going to divide through by 2. And when I divide through by 2, you realize that some angles will still qualify to lie in the range, 0 degrees less than or equal to beta, less than or equal to 360 degrees. Yes, so when I divide through by 2, I'll have my beta being equal to 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Yeah, that's when tan 2 beta is equal to 0. If you have a question, you can unmute and ask. I might be able to see your hand. Yeah, then considering the portion where 3 minus tan squared 2 beta is equal to 0, which angles are in that, which angles would qualify? So when 3 minus tan squared 2 beta is equal to 0, that can be written as tan squared 2 beta is equal to 3. Therefore, tan 2 beta, if I take square root on both sides, I'll have root of 3. Yeah, so remember when I get square root of a number, I have 2 values, the positive value and negative value. You shouldn't forget that. Some people may just choose to go with a positive value only. So it means that tan 2 beta can be equal to plus or minus root of 3. So when tan 2 beta is equal to the positive value, root of 3, means that 2 beta will be equal to tan inverse of root of 3. Yeah, so remember our ratio is positive, so look for quadrants where tan is positive, which are the first quadrant, and then the third quadrant. Angles in the third quadrant are got by adding 180 degrees to the acute angle we have in our first quadrant. The positive angles in the third quadrant are got by adding 180 degrees to the acute angle we get. Yeah, so I'll have my 2 beta being equal to tan inverse of root 3 is 60 degrees. So 60 degrees. And the third quadrant angle will be 240 degrees. 180 plus 60 degrees. Then when I add a whole revolution to 60 degrees, I'll have 420 degrees. I add 360 degrees to 240 degrees. I'll have 600 degrees. 600 degrees. Yeah, so when I divide through by 2, I'll have my beta being equal to 30 degrees. 240 by 2, I'll have 120 degrees. 420 by 2, I'll have 210 degrees. 600 by 2 will give me 300 degrees. Yes. Then we're also looking at the negative value that has been for the positive value. So we also look at the negative value. Yeah, so when tan 2 beta is equal to negative, root of 3, it means that 2 beta will be equal to tan inverse of negative root of 3. Yeah, so our ratio is negative, which means that we are going to look for quadrants where tan is what? Where tan is negative. And those quadrants are the second and fourth quadrant. So angles in that quadrant, and then angles in the last quadrant. Yes, so angles in the second quadrant are got by subtracting theta from 180 degrees. So in the second quadrant, we shall have 180 degrees minus theta, whereby theta is the acute angle, the angle in the first quadrant. In this case, when I drop the negative and take tan inverse of root of 3, I get a 60 degrees. So to get angles in the second quadrant, I'll have 180 minus the 60 degrees. That's what I'm talking about. Then angles in the third quadrant. So second quadrant, it's 180 degrees minus theta. Then third quadrant, it is 360 degrees minus theta, theta being the acute angle we get, taking tan inverse of root of 3. Yes, so I'll have 180 degrees minus 60 degrees, since we have root of 3. So 180 minus 60 degrees will give me 120 degrees. Then 360 degrees minus 60 degrees will give me 300 degrees. Yeah, then when I add 360 degrees to 120 degrees, I'll get 480 degrees. Then when I add 360 degrees to 300, I'll have 660 degrees. Yeah, you can also get other angles by adding 360 to maybe 480, but they will actually lie out of our range. Yeah, so it means that beta will be equal to 60 degrees when I divide through by 2. Then 300 by 2, I'll get 150 degrees. 480 by 2 will give me 240 degrees. And 660 by 2 will give me 330 degrees. So I'll conclude by listing all the angles I've got. I have these angles here, and these ones. So my final answer, I can arrange them in ascending order. So it means that the values of beta are equal to, our first angle is 0 degrees, then 30 degrees, 60 degrees, 90 degrees, 120, 150 degrees, 180, 210, 270, 300 degrees, and lastly, 330 degrees. Yeah, so those are our solutions to the second question. Any questions? Okay, since no hand is raised, I guess we have no question. I'll hand over to the next. Oh yeah, Shakira, you can ask a question.
I thought for this question, when they ask us for the limits from 0 degrees, okay, between I think this limit means that between 0 degrees and 360 degrees inclusive, not so? Then
Yes.
for this revolution, this first revolution where we had 2 beta is equal to tan inverse of 0 degrees, I thought that when you're making the revolutions of 360 degrees, you're supposed to add on 720, such that,
720.
yes, so that
Okay.
among our answers, you're also having the 360 degrees inclusive.
Yeah, that's correct. Since I said between 0 and 360 degrees inclusive. Yeah, thank you. So it means that 360 is also among the angles. Yeah, thank you very much. Yeah, I guess that was it for question 2. I'll hand over to the next discussant for question 3.
Hello everyone. You're welcome to this seminar. The questions have been sent in the chat. If you're wondering where we're getting the questions from, and the link to the seminar has also been sent in the chat. Yes, this is question 3, and it's a vectors question. The points A, B, C, and D have coordinates, as you can see them respectively. And we've been asked to find the vector equation of the line PQ, where P divides AB in the ratio 2:3, and Q divides CD in the ratio 1:4. So you're seeing that we need knowledge from our ratio theorem, because we're looking at division of line segments, and then we also need knowledge of the line because we're looking at finding the vector equation of the line. So of course, to find the vector equation of the line, we'll first need the coordinates of point P and the coordinates of point Q. Now, being told that P divides AB in the ratio, P divides AB in the ratio 2:3. Both these divisions are internal. They're implied. Then them being internal is implied because there is no negative sign on any of the parts of the ratio. So this is 2 to 3. The ratio theorem tells us that means the coordinates of the position vector of point P will be got from 3 times OA plus 2 times OB divided by 3 plus 2. So you multiply, the 3 is closer to the B, it's associated with the B, but we multiply by the position vector of A, and vice versa, the 2 with the 1 of B. So this should give us the position vector of A is simply given by the coordinates of point A. So that's going to be 3 times -7, 9 plus 2 times 3, 4. Is that right? And this is divided by 5. This is divided by 5. And so when you actually go ahead to compute this, you have in your numerator you have -15, 35, but you're going to be dividing this by 5, so multiplying it by a fifth, and this gives us -3, -37. So we have the position vector of point P. Similarly, we can get the position vector of point Q because Q divides CD in the ratio 1:4. So similarly, we'll have that the position vector of OQ is 4 times OC plus 1 times OD divided by 4 plus 1. This is going to be 4 times 1, 2 plus -2, -9 divided by 5. That's going to be a fifth multiplied by, we have 2 and -1. That's going to be 2 out of 5, -1 out of 5. Okay, so now that we have the position vectors of P and Q, how do we get the vector equation of a line? So vector equation of the line R is usually given by a point on the line. So we could go with point P plus lambda times the direction of, lambda is any parameter that changes along the line, lambda times the direction vector of the line. And so how do we get the direction vector of the line? Direction vector of the line is simply the vector between any two points on the line. So since we have point P and Q on the line, since it's the line PQ, since we have point P and Q on the line, our direction vector can simply be the vector PQ. So we can go ahead to find that PQ is going to be OQ minus OP. So that's going to be 2 out of 5 minus -3. Negative 1 out of 5 minus 7. This is going to be 17 out of 5 and negative 36 out of 5. And so our vector equation of the line is going to be R given by OP, which is -37, plus lambda times 17 out of 5, negative 36 out of 5. But if you don't have the out of 5 there, you could simply just write it as -37 and then change the parameter to mu times 17, negative 36, where mu is going to be equal to a fifth times lambda, since you'll have factored out 1 out of 5. Yeah. So this is how you get the vector equation of the line. Any questions? Yes, Shakira.
I request for some more clarity on this beginning part where we have the lines AB and CD.
Yes.
Someone explain it.
Okay, so here what we've used basically is ratio theorem. You know about ratio theorem, right?
Yes.
Yeah, so ratio theorem tells us that if a point P divides a line segment AB in the ratio 2:3, yeah, it's an internal division, because from the question it tells us in the ratio 2:3 and CD in the ratio 1:4. So there we know it's an internal division because there is no negative that has been used on any parts of the ratios. Okay.
Yes.
Yes, and so here we're simply substituting in the formula for finding the coordinates finding the position vector of a point that divides a line segment into a particular ratio. So this 3 goes with the position vector of A, yet it's on the side of B, and the 2 goes with the position vector of B, yet it's on the side of A. That's how it's done. There's a proof for this in our vectors playlist in the math app, on the math app channel, if you want to look at it. I don't want to go through it now because there are many other questions that we can look at, but that's simply what we've done.
Thank you.
Okay. If there are no other questions, then I'll move on to question 4, which is a question from differentiation, small changes. Yeah, so using calculus on small changes, we've been asked to find the approximation of sec of 44.6 degrees squared. Now, one thing you should be careful about is that differentiation is valid for angles in radians. So you want to change this to radians first before you actually go ahead and do the question. But what do we do in small changes? We first identify the function that's being talked about, and this is y is equal to the sec of x all squared. But we know from our knowledge of trigonometry that we can write this as 1 plus the tan of x all squared. Now, which angle close to 44.6 degrees do we know has an exact sec value or tan value? We know that 45 degrees, tan of 45 degrees is 1. So this suits our function very well. So we choose x naught to be 45 degrees. 45 degrees is pi over 4 in radians. Because we know that its tan value is easily computable and is known that the tan of 45 degrees y naught, which I'm going to write as 1 plus tan, the tan of x naught squared is going to be 1 plus the tan of 45 degrees, tan of pi over 4, which is 1, and so y naught is 2. Okay. And what is our delta x? Okay, so our delta x is the change in x from 45 degrees to 44.6 degrees. So our delta x is going to be 44.6 minus 45. This is in degrees, but of course you can, eventually change this to radians. So this is negative 0.4 degrees. When you change it to radians, it's going to be negative 0.4 times pi out of 180. Okay, what else do we need? We need dy dx. Yeah, because the path we're using is that we're going to get, we have a y and an x naught, and we want to say that y naught plus delta y, which is what we want to find, is going to be equal to the function operating on x naught plus delta x. X naught plus delta x. This is what we want to approximate it to, and now this is what we want to get. So we need to get delta y now. Delta y is what we approximate to dy dx, which is the gradient function, multiplied by delta x. This is the approximation that we make. That's why it's called an approximation. Because in reality, if you have a curve that's something like that, and we're looking at approximation along the tangent, there. So the point that might actually be this side, we're going to approximate it to be something like this. That's what's going on. So we're assuming that it's a straight line whose gradient is given by dy dx, because dy dx is the gradient function. So that's basically what we're doing. Yeah, so dy dx, given the function, we have the function as the sec of x all squared. When you differentiate the sec of x all squared, power becomes a multiplier, and then you differentiate the function. When you differentiate sec, you get sec x tan x. So you're going to have times 2. You're going to have that raised to the power 2, and then multiply by a tan x. But we know that this is simply 1 plus the tan of x all squared times tan x. Okay, so to get delta y, the change in y, the approximate change in y, we're going to have dy dx calculated at when x is x naught, that known point that we've chosen, and then multiplied by delta x. So this is going to be 2 times 1 plus the tan of pi over 4 squared times the tan of pi over 4 multiplied by our change in x, which is negative 0.4 pi out of 180. Now we know that tan of pi over 4 is 1, so it's just going to be 2 times 1 plus 1, which is 4. 4 times 1 is 4. So this is going to be negative 1.6 pi out of 180. So this is our change in y. And so the sec of 44.6 degrees, which we're writing as the sec of, you write this in in radians, 44.6 pi out of 180, and we approximated to be, it's going to be y naught plus delta y. So our y naught is 2, our delta y is 1.6 pi out of 180, and this is equal to 4 decimal places, this is 1.9721 to 4 decimal places. If you actually go ahead to calculate the sec of 44.6 degrees and then square it, what you'll get is actually 1.9725 to 4 decimal places. So it's a fair approximation. It's correct to 3 decimal places. Yeah. Any questions there? Okay. If there are no questions, again, this is also available in the differentiation playlist on the MathHub channel. So if you want like further explanation of small changes, you can go ahead and look at that. Let me invite the next discussant to take us through number 5.
Yes, this was our fifth question in our paper 1. It reads, find the locus of a point Pxy, which moves such that its distance from the point, this was S negative 3, 0 is equal to the distance from the fixed line S is equal to 3. So you can start by drawing a simple sketch. It might be necessary, it might carry marks, but it could help you visualize what you're working with. So they're telling us that the distance from a point Pxy, I can put that point anywhere in my plane. So let me choose to put it here. We're saying that the distance from that point, Pxy, to the coordinate S negative 3, 0, assuming this is the coordinate. So this distance is equal to the distance of the point Pxy from a fixed line X is equal to 3. So assuming this is my line, X is equal to 3, passes through the X coordinate, which is parallel to the Y axis. So the distance from the point Pxy to that line is equal to the distance SP from this coordinate to that point P. Yeah, now when you're talking of a distance from a point to a line, they always mean the perpendicular distance. That's one thing we shouldn't forget. So it means that the distance we're talking about from the point to a line is actually a perpendicular distance. I can call this point where the perpendicular has been dropped. I can call it point T. This is our line, X is equal to 3. So the condition for that locus is that the distance SP is equal to the perpendicular distance TP. That's the condition you're working with. So here it means that I must be aware of the formula for getting distance of a point from a line, the shortest distance, which is also called the perpendicular distance. Then I must know how to get the distance between 2 points, which is quite easy. Now the formula for getting the perpendicular distance or the shortest distance of a point to a line is in your logbooks. That's if you can't remember it. Yeah, so I'll substitute my values. So distance SP is distance between 2 points. So if I substitute, I'll have square root of 1 minus 0 squared plus x minus negative 3, but squared is equal to the distance TP. Now for TP, I'm going to apply the formula for getting perpendicular distance I've told you. So now that if I'm getting, let me just quote it here. If I'm getting the distance between the points Px0, y0, I can use ax0, y0, and the line ax plus by plus c is equal to 0. That distance is equal to the magnitude of a times x0 plus b times y0 plus c out of the square root of s squared plus b squared. That's a formula I'm going to use for distance TP. Substituting into that formula, I know that in this case, our line is x is equal to 3, and our coordinate is P, x, y. So I'll have magnitude of A. My A is the coefficient of x, which is just 1. So my A will be equal to 1 times the x coordinate of our point, which is x, plus my B is the coefficient of y, but our equation is just x is equal to 3. So I'll have 0 times the y coordinate of our point, which is y, plus c, which is 0, out of root of 1 squared plus 0 squared. Yes. So I'll square both sides. get rid of this square root, and I'll have x plus 3 squared plus y squared is equal to, yeah, so when I simplify this, 1 times x, I'll have x. Then 0 times y is 0 plus 0. So I'll have it as x squared. I've squared both sides. Yeah, then when I expand what I have here, I'll have x squared plus 6x plus 9 plus y squared is equal to 0. Yeah, so is equal to x squared. Sorry, is equal to x squared. So I think you realize that x squared will go, and I'll be left with y squared plus 6x plus 9 is equal to 0 as my locus. Yes, so that's our answer for that question. Any questions? Okay, if we have no questions, I'll hand over to the next discussant for question 6. Oh, yes, Nicholas. Nicholas, you can submit. Okay, let's hear from Mark. Mark, your hand is raised. You can submit. You can unmute and submit. Okay, maybe we shall hear from these people later. Let me hand over to Harvey to discuss the next question.
Maybe they can have type their questions in the chat. If Mark and Nicholas, was it? Yeah. Just before we proceed, you can type your question in the chat. So that we can handle that before we proceed. Okay. So yeah, so Brian, I don't know if you can see the questions. For Mark, it was about the perpendicular distance. He didn't get how the perpendicular distance worked. And then for Nicholas, it's that he thought the value of C was supposed to be -3.
All right, let me go through this very fast so that yeah, so that distance, the formula is in the logbook. We cannot derive it from here right now because of time factors. So the distance is, okay, if I have a line AX plus BY plus C is equal to 0, and I want to get the perpendicular distance of a point A, X naught, Y naught from that line, that distance is equal to the magnitude of A times X0 plus B times Y0 plus C out of S squared plus B squared. So let us go back to our equation. I'm getting the distance from the line X is equal to 3 and the point PXY Yeah, so for this equation, I can first write it in this form of ax plus by plus c is equal to 0 by taking the 3 to the left-hand side. So I'll have x minus 3 is equal to 0 and pxy. So it means that that distance, d, will be equal to the magnitude of a, which is the coefficient of x, that is 1 times x, plus b, which is the coefficient of y, that is 0 times y, plus c, which is negative 3, as someone has said, out of a squared, but a is 1, so 1 squared, plus b squared, but my b is 1 since I don't have, okay, it's just x minus 3 is equal to 0. So I'll have it as 0 squared. So d will be equal to x minus 3 out of 1. Yeah, so that distance x minus 3, which is a perpendicular distance, it's equal to the distance SP, which we had previously, which was x minus negative 3, but squared, plus y minus 0 squared. So if I square both sides, I'll have x minus 3, but squared is equal to x plus 3 squared plus y squared. Then when I expand that, I'll have x squared minus 6x plus 9 being equal to x squared plus 6x plus 9 plus y squared. So I think you can say that x squared goes, and I'll have the x squared and 9 also goes. X squared, 9, and I'll have y squared plus 12x is equal to 0. Yeah. So your equation has to be in this form, ax plus by plus c is equal to 0, for you to apply that formula, which is in your logbook in case you didn't get it.
Yeah, so I hope the questions have been answered. I'm going to come in with question 6. I hope you can all see my screen. Right. Yes, so question 6 is on integration. We have to integrate 1 out of root x times the cos of root x all squared. Now usually you just go straight into the change of variable because there's no way you can just do this directly. Unless of course you're looking at, okay, what happens when I differentiate root x? When I differentiate root x, I get 1 out of root x, 1 out of 2 root x. So you could say, oh, this is function and its derivative. But changing variable is the simpler way to do it, and that's what we're going to do. So we'll let u to be equal to root x. And then what we're going to do is square both sides so that we can have, we can do away with the square root. And then afterwards, we'll differentiate both sides with respect to x. And when you do that, you'll have that 2u du dx is equal to 1. And so we have that dx is simply 2u du. Okay, so what does this mean? This means that the integral of 1 out of root x times this right here with respect to x is in fact equal to the integral of 1 out of u times the cos of u squared, all this multiplied by 2u, then we're integrating this with respect to u. What does this leave us with? So we'll have a 2. We can have the 2 on the outside, and then times the integral. The u's will, take each other out, and so we'll just have the cos of u squared with respect to u. This is where your trigonometry comes in again. Because to integrate this, we need the identity, the half angle identity. And we'll use the fact that cos of 2x is equal to 2 times the cos of x squared minus 1. So this tells us that this is in fact equal to a half times cos 2x plus 1. And so similarly, this is equal to a half times the cos of 2u plus 1 with respect to u. Now the 2.5 take each other out as well, so we just have the integral cos of 2u plus 1 with respect to u. Now we know that the cos of 2u comes from a half sine 2u, because you know that when you differentiate sine of u, you get cos u. So the cos of 2u should have come from a half of sine 2u. You divide by the derivative of the angle, and then just replace it with the function which it came from. Now when you integrate 1 with respect to u, you should get u, and then we have an arbitrary constant of integration. But then our original question was in terms of x, and so we should leave our final answer in terms of x. So it's going to be a half sine 2 root x plus c. Any questions? Okay, so I'll assume that there are no questions.
I'm
Yes, Lucas.
how do you know what to make the u between cos squared root of x and only root x?
A lot of integration actually you do by experience and intuition. Yeah. So the question of how do you know, I would say by experience, you sort of look at questions and see that, this substitution would actually work. But then also knowing that if a function is appearing with its derivative, then it's better to just substitute that function. So you see that I have root x here. There are many functions here. There's root x, 1 out of root x. There's the cos of root x, and then all that being squared. But you know that when you differentiate root x, remember root x is x to the power half. When you differentiate root x, you get a half times x to the power negative half, which is in fact 1 out of 2 root x. And you see we have a 1 out of root x as in part of the entire function as well. So once you see a function and its derivative, it's always advisable, if you're going to change variable, to let the function that's appearing, whose derivative also exists, to let u be equal to that function. Yeah.
I have a question.
Is that okay, Dorcas? Before you come in, I just want to make sure that Dorcas is okay.
Yes, thank you so much.
Yes. Who had a question? Was it Abraham?
No, it's me, sir.
Yes, Ismail.
Here when you we pulled out the 2, but then you never put it also in the final conclusion after we put in the cos u plus 1. Where did the 2 go?
Oh, the 2 went to this half here. The 2 went to the half.
Yes, sir.
Is that okay, Ismail? The 2 went to the half right there.
Yes, I do get it now.
Yeah. Simon had a question in the chat. Let me just answer that very fast. Simon, your question was elaborate how the cos of u squared becomes a half times. Okay. Yeah. So I use this substitution from the double angle. The double angle for cos, that we know that cos of 2x is equal to 2 times the cos of x squared minus 1. So if you make this the subject, this is what you come up with, a half times cos of 2x plus 1. So that's the same thing I used for u. The angle has just changed from x to u, but it's the same thing. Simon, I hope that answers you. Okay. Nice. Okay, so we'll move to question 7 then. Yeah, so question 7 is a simple question, simultaneous equations, but you've been asked specifically to use the echelon method. So the first thing you do really is to turn this into a matrix, to turn this into matrices, yeah, products of matrices. And so the coefficients have actually already been arranged for you. It's x, y, z in all the 3 equations. So you could write this as 2, -1, 3, 1, 4, -1, 3, 1, 4. This is being multiplied by x, y, z to give us 14, -5, 17. Yeah, so what you want to do is to carry out row reduction. So row reduction means we carry out, linear operations between the rows. You replace a row with a linear combination of that row and one of the other rows, since there are just 3 rows. So the aim of this is to make this a diagonal matrix, and a diagonal matrix is, to make this either a diagonal matrix or upper triangular matrix. So an upper triangular matrix is basically one where this would be a 0, this would be a 0, and that would also be a 0. So that would be upper triangular. And the aim of that is such that we'll simply be able to just, have the equations that will just give us the answers, the solutions to our unknowns straight away. So that's the aim. It's really like elimination, yeah? It's like we're doing an elimination method, because when you see, if you actually check what we're actually doing, what we're doing with matrices is actually, just multiplying an equation by maybe a certain factor and then subtracting, with another equation to give us another equation. Yeah. So don't let it confuse you. It's basically just elimination, really. Yeah. So the first step is to make these 2, the 1 and 3 that appear in the first column, to make them zeros. And we'll do that with operations using row 1. So we'll replace row 2. We'll replace row 2 with, we can do it 2r2 minus r1, because we want to make this one a 0. So if we multiply this one by 2, we'll get 2, and then we can subtract the 2 in row 1 from it. So we'll do that for all the elements in row 2. And then for row 3, we can replace row 3. We can multiply row 3 by 2, and then subtract 3 times row 1 from it, because you see here we have a 3 and a 2. If you don't want to deal with fractions rather, then it would be better for you just multiply this by 2, multiply row 1 by 3, and then do the subtraction afterwards. Yeah. So now we effect these operations to every element that appears in the row. Of course, we won't do this to x, y, z, but we'll also do it to the solution matrix. So row 1 remains unchanged. We have 2, 1, 3 still appearing there. You could actually combine these matrices and just write them like this. This is called the augmented form. Yeah. And then row 2 has changed to 2 times row 2 minus row 1. So what was 1 now becomes a 0. We'll have 2 times this. 2 times 4 is 8. And 8 minus 1 becomes 9. And then what was -1? -1, we'll have 2 times that, which is -2. And -2 minus 3, that's -5. And then also for -5 here in the solution, so we have -5 times 2, which is -10 minus 14. That's going to give us -24. So we do a similar thing for the elements in row 3. 2 times 3 is 6 minus 3 times 2. That's going to give us 0. 2 times 1 is 2 minus 3 times minus 1, that's going to give us a 5. And then 2 times 4 is 8, minus 3 times 3, that's going to be 8 minus 9, which is -1. Then 2 times 17, which is 34, minus 3 times 14, which is 42. 34 minus 42, that's going to give us -8. Okay, so we've made these 2 zeros. Now we just need to make that 5 a 0. So what do we do? To make it a 0, we shall perform an operation between R3 and R2. The reason why we're using R2 now is because these two are already zeros. So no matter what, what I multiply them by, it will always still maintain those zeros. However, if I did R3 with R1, I'm not sure that this would remain a 0. So I should take R3 with R2. So what am I going to do? I'll have 9. I replace R3 with 9 times R3 minus 5 times R2. Why am I doing that? Because I have a 5 and a 9 here. So that's basically my aim. So when I do that, my matrix now becomes 2, -1, 3. Row 1 is unchanged. 14. Row 2 is also unchanged. This is 0, 9, -5. -8 is -72, minus 5 times -24, which is 120. That's going to give me positive 48. I hope I wasn't breaking there. I hope you can still all hear me. Yeah. So we have reached the end of our row reduction. So we have used the row reduction to get this. Now we can extract equations. Now when we extract equations, we'll have that 16z is equal to 48. What does that mean? Divide both sides by 16, you have your z is equal to 3. So that's from that last row there. Yeah, that's from row 3. From row 2, we have that 9y minus 5z is equal to minus 24. So that means that 9y is equal to 5z minus 24. But we know that z is 3. So that's going to be 5 times 3, 15 minus 24, which is -9. Therefore, your y is -1. And row 1 tells us that we have 2x minus y plus 3z, and that's equal to 14. But if you substitute for y and z, since we already have their values, you end up getting your x as 2 when you solve. So you have your solution as x equal to 2, y is equal to -1, and z is equal to 3. Which is funny because those actually they are coefficients in the first equation. And you can always check with a calculator. Actually, whenever you do a question on simultaneous equations, I always advise you to get the answer in the calculator and then make sure that your final answer, when your final answer looks like that. Yes, Melissa, your hand is raised.
So I realize we are to use the echelon method, but we haven't done anything concerning that. We just used row reduction.
So what would you want to do? Reduce.
Yeah, reduce until your coefficients are 1, and then
this is it. So there's, what's it called? Row reduction, and then reduced. There's row reduction, and then there's further row reduction. So you're actually allowed to stop at this point. They are still both part of the echelon method actually. One just goes further. Yeah. So you could actually stop here and just give the answers. But which is what I've done. Or like you're suggesting, you could go ahead to make it a completely diagonal matrix, and then that would involve making that a 0, making that a 0, and making that a 0, so that it's just elements along the main diagonal. So whatever we've done to row 2 and row 3, you'd have to do again to row 2 and and row 1. So you'd have to make those two zeros and make that a 0. So you could do that, yeah, but it's cumbersome, which is why I've not done it. But this is still correct though. It's not. It's just a shorter, a shorter version. Okay. If there's no other questions, then I think we can proceed. Yeah. So question 8 is rates of change. The surface area of a sphere is decreasing at a rate this when the radius is 0.6 meters. We must find the rate of change of the volume of the sphere at this instant. Okay, so what do we know? We know that surface area of a sphere is 4 pi r squared. So we can find the ADR, and this is going to be 8 pi r. What do we need? What do we have? So we want to get the VDT, yeah? But we know that from our knowledge of rates of change and the chain rule, the VDT should be equal to the VDR times the RDT. We know the VDR because we know that there's an equation that relates volume and the radius of the sphere. The volume of a sphere is given by 4/3 of pi r cubed. So we need the RDT. How are we going to get the RDT? We've been given the ADT. So we can get the RDT again using the chain rule from the RDA multiplied by the ADT. Now what's the RDA? The RDA is simply the reciprocal of the ADR. So that's going to be 1 out of 8 pi r multiplied by the ADT, which is 0.9 meters squared per second. I'm not going to put the units here, I'll just put them at the end, but it's always good to know what units you're dealing with. Yeah, so this is simply 0.9 out of 8 pi r. I advise you to always leave pi in your answer until like you've reached the very end of your answer, because in questions like this, it's bound to, to find a way to disappear. Yeah, so what's my V? I know that, like I just said, the V is 4/3 times pi r cubed. And so the VDR is actually 4 pi r squared, which is also the surface area. It's not a coincidence, but we won't get into that. So how do we get the VDT? So the VDT is going to be the VDR, which is 4 pi r squared times our DRDT, which is 0.9 out of 8 pi r. I'm using a huge dot in the middle to mean multiplication. Yeah? And what does this give us? What does this give us? This gives us 0.9 r. 0.9 r divided by 2. You see the pi goes away. The 4 is reduced. The 8 is reduced by the 4 to 2. And we just have 0.9 r out of 2. But our r was, I'm just writing this in. So the VDT, when r is 0.6, it's going to be 0.9 times 0.6 divided by 2. So that's 0.54 divided by 2, which is 0.27. This is our volume, yeah, the rate of change of volume. So it's going to be meters cubed per second. Yeah. Any questions there? Formula for surface area of a sphere in the logbook. Yes, it's in the logbook. So that should be the least of your worries. It might also be in a mathematical set, I think. Those are things that come in the set. Yeah. Any other questions? Yeah, so it's basically chain rule applied. Whenever it's rates of change, you're always going to apply chain rule. So what you need is usually be given one rate. You'll need the equation relating the two variables, and then you'll be able to find the other rate of change. Yeah, it's just that in this case, we're dealing with, two pairs of variables, A and R, and then V and R, but we can use one to get the other like we've done. So I'll pass on to our next presenter, who's going to take us to section 8 of paper 2.
Okay. Morning once again. We are going to start on paper 2. The questions are going to be shared in the chat shortly. But for the moment, as you can see on the slide, there is question 1. Yes, the questions were as well shared in the WhatsApp groups. You could also access them from there, but still, we shall share them here in the chat. And you can as well be able to access them, those who have just joined or those who are not in the group. So we shall jump straight into question 1, and it's about interpolation and extrapolation. These are very easy topics. I don't think this should be a problem for anyone. However, yeah, we can even take a very short time on such a question because it's really easy. So they are saying using interpolation, linear interpolation, extrapolation, find the tangent of 25 degrees, 18 minutes. So we can see that our table is that we have been given the tangents of 25 degrees but at different minutes. So here in question, we are looking for 18 minutes, and we can see 18 lies before 24. So we can just have a rough sketch of the table like this. Where this is the degrees, and this is tan, 25, this is 18, this is 24, and this is 30. So we are looking for what here? Let me call it y. We already have here 0.4748, and here we have 0.4770. So yeah, interpolation and extrapolation are based on the gradient method. So it is fair to say that y minus 0.4748 divided by 18, you could actually neglect the units here. 18 minus 24 has to be equal to 0.4770 minus 0.4748 divided by 30 minus 24. And evaluating this has to give us an answer close to 0.4748, but less than it. And therefore we have 0.4726. You can help me verify that. Then next, we're going to find the arctan of that 0.4775. And in doing that, they're literally asking us for the angle that gives 0.4775 as a tangent. So that implies I have to locate where 0.4775 lies, and it lies between 30 minutes and 36. So I'm going to sketch a table, and I'm looking for that angle between the two, or the minutes between the two. Here I have 0.4770. We have 0.4775, and you have 0.4791. So theta, beg your pardon. So theta minus 30 divided by 0.4775 minus 0.4770 has to be equal to 36 minus 30 divided by 0.4791 minus 0.47 0.4770. Evaluating this is going to give us our theta as 31. Yes, there are going to be decimal places, but those could be neglected as well, or you could round off since we are dealing with minutes that have no DPs. So that is our solution for number one. Are there any questions? Okay, looks like there are no questions, so shall proceed to the next. And that will be presented by my colleague, Brian.
All right. Our second question was from statistics, and particularly price indices, relative indices. Maybe I can have it put here. Yeah, so it reads the price relative of a commodity in 2001 using 2000 as the base year was 105. Then the price relative of the same commodity in 2002 using 2001 as the base year was 95. Given that the cost of the commodity in 2000 was $120, find the cost of that same item in 2002. Yes, so we are dealing with price relatives, and we must know the formula for price relatives. So I've told us that the price relative of that commodity in 2001 using 2000 as a base year. So if 2000 is the base year, we can write our expression as price of the commodity in 2001 out of price of the commodity in 2000 times 100, which is our formula for price relative. They have told us that that price relative was 1,500. I can go further and simplify that. I'll end up with price in 2001 out of price in 2000. If I divide through by 100, I'll get 1.05 as my answer, which means that the price of the commodity in 2001 is equal to the price of that commodity in 2000 times 1.05. So I'll have 1.05 times the price of the commodity in 2000. Yes. Then they have told me that given that the cost of the commodity in 2000 was $120, find its cost in 2002. Yeah, and we're using 2000 as our base year. Sorry, beg your pardon. So that the price relative of commodity in 2001 using 2000 as the base year was 105. Then the price relative of the same commodity in 2002 using 2001 as the base year was 95. So 2002 using 2001 as the base year. So price of the commodity in 2002 using its price in 2001 as the base year times 100, that price relative was 95. So if I divide through by 100 and make price of 2002 the subject, I'll end up with price of 2002 being equal to 0.95 times price of the commodity in 2001. I've divided through by 100 and multiplied by price in 2001. Yes. So I have two expressions. I have expression 1 and expression 2. But then I've been given the price of the commodity in 2001. So in 2000 as $120. So price of commodity in 2000 is equal to $120. So I can come here and substitute it into this equation to get the price of the commodity in 2001. So price of the commodity in 2001 is equal to 1.05 times the price of the commodity in 2000, which was $120. And when I multiply that, I get $126. So that was the price of the commodity in 2001. Now, since I have the price of the commodity in 2001, I can come into this equation and substitute it there to get the price of the commodity in 2002, which is actually what the question wanted from us. So I'll have price of the commodity in 2002 is equal to 0.95 times price of the commodity in 2001, which was $126. So price of the commodity will be equal to $119.7. So that is what they wanted us to get from our question. I hope that's clear. Any questions? Yes, Nicholas. Nicholas, you can unmute and ask your question, or you can type in the chat. You can type it in the chat. Okay, he has lowered his hand. I don't know whether it's now clear to him. Maybe we can proceed. If at all there is no other question. Can't see Nicholas.
Okay. I think we'll proceed with question 3. I don't know if Nicholas will be, I don't know if Nicholas was sorted or not. Anyway, let's start with the question. It says a car traveling at 80 kilometers per hour on a rough incline plane of incline 1 in 80 has a mass of 420 kilograms and accelerating at a rate of 1.5 meters per square second. The power developed is 5 kilowatts. Find the friction force. So of course, this is mechanics, and it is important that for any mechanics question you're doing, you should sketch. A sketch will be very important in helping you interpret the question. So the car is traveling at that speed. It's traveling on an incline at of that specification, and its mass is given. So we shall just sketch a small an incline here. 1 in 80 means the person for every 80 meters, for every 80 units, he travels horizontally. He has risen by 1 unit. So that's why we have 1 here, and we have 80 here. So we can call this our angle theta. Yes, so yeah, we have a car. Let me represent it as this. It is, the direction of this motion is not given, so we can make an assumption, which will later be checked by the final answer. So we can see that the car is going, let me say it's going up. Let me assume upward motion. So there is a certain driving force, let me call it FD. And of course, since it's going up, each component of mass acts downward. And this is 420 G. So you have 420 G divided into a component here and a component perpendicular to the plane. And this would be 420 G sine theta. This is 420 G cos theta. And remember, they've asked us to find the friction force, so there has to be a certain friction. And since it's going up, I expect the friction F to point downwards. So I am going to resolve these forces horizontally along the plane and perpendicular to the plane. So along the plane, no, 1 in 80 should not be, I do not think it's a sine ratio, because it means that I have moved, it means you move one unit upwards when you move through 80 units horizontally. I do not think it directly implies that it's a sine ratio. I do not know if that is clear. Yes, it's a tan ratio. So that means our tan theta is 1 over 80. Yeah, for which we can find our angle. As arctan of 1 over 80. Yes, the angle is 0.7162. degrees. So we shall resolve horizontally and, parallel to the plane and perpendicular to the plane. Parallel to the plane, we have FD. FD is equal to half F plus 420 G sine theta. Yeah, but FD, our driving force, can be obtained from power, because power is equals to the driving force times the velocity. We have power as 5 exponent 3 times the velocity u, which is 80 kilometers per hour, but we have to change it to meters per second. And therefore, we multiply by 1000 and divide through by 3600. The normal reaction acts perpendicular to the plane, and I'm resolving parallel to the plane. In other words, I'm looking at the forces that are acting in this sense. Yeah, the normal reaction would act in that sense, that's perpendicular. So since it's acting perpendicular, it has no component along the plane. So my FD is going to be 225 newtons. So I have 225 is equals to F plus 420 times 9.81 sine of 0.7162 degrees. And we can proceed to find our F. Oh, okay. We'll explain that in a few. Let's first have our final answer. Our final answer is going to be 173.55 newtons. So the question that has been asked about why the power component is the second expression of sine, it is really simple. Let me just have the inclined plane and the weight. So I have, this is the weight mg. It has a component here, and it has to have a component. Let me say it's coming from the center, and it also has to have a component along the plane. So the angle of inclination of the inclined plane theta is the same here. You can kindly check that out later on. Yes, then resolving mg will give you these components as mg cos, and it's going to give this component as mg sine theta. And with that is why we have sine that is parallel to the plane, and the cos component is perpendicular to the plane. Yes, however, that is how we would go about this question. And I mentioned something at the start about how the final answer would help us know whether the body is going up or down. And it's clear that it is going up, but I beg your pardon, we may have to, there's something we did not consider, and that is 1.5. So I request to explain this one more time. There's something we excluded in these equations. So the answer may not be 173. So we shall have, yes, we are resolving upward. Let me say, yes, the body is going up. So that means the resultant force of this body has to be upward. So that means, okay. Could you please re-explain why the incline is the identity of tan? It's the identity of tan because I said this expression, this statement means that the body rises 1 unit vertically and 80 units, moves 80 units horizontally. So that is why this is tan. And as I represented it here, you have 80 and you have 1 on the vertical part of the incline. Yes, as I was mentioning that, yes, the body is moving up, so the resultant force has to act upwards or up towards the plane. So that means I have to have FD. There has to be MA here. Thank you, Reggie. Thank you, Letitia. So there has to be an expression of MA here. So here we had to have 420, sorry, times 1.5. So our real value for the friction force, okay, I said the velocity, yeah, that's what it means, Nicholas. Velocity, I got it from the expression of power, because power can be written as an expression of force times velocity. That's why we have it here. And that is what I used. And the force that, in this case, we're looking at a car. So the force that we have here is the driving force that is generated by the engine. In other words, the force that is causing the car or the body to move upward. So we have P as being a product of force and velocity. And since we have the power and we have the velocity of the car, then we can be able to get the driving force, FD. And therefore, we got our driving force as 225. So I don't know if that is okay. It looks like it's okay. Otherwise, as I was saying, we have to get our answer for the friction force as 8. Okay. All right. Polar. The friction force is 803.498 newtons. So that is our friction force, and that is our question 3. I think we can go ahead to question 4 if there is no other question from what has been shared. Yes, question. Let me go back. Yes, Faith, as I mentioned, MA is the resultant force. You see that on this body or on this car, there are very many forces acting on it. You have the component of the weight. Yes, as I explained from here, we shall deal with the components of the weight. The weight acts on the body in 2 different directions, perpendicularly and parallel to the plane. And we resolved the components as this mg cos theta and mg sin theta. Those are the forces acting on the body. Another force was friction. Friction was as well acting on the body. And that is what we wanted to find. Then another force that is acting on the body would be the driving force, or the force that is causing it to move upwards. That is FD. So in all of these forces that are acting on the body, there has to be one resultant force. In other words, the resultant force can be explained as that force that has the equivalent effect on a body as all these other forces that act on it. So that is why we have to have MA. And the resultant force acts in the direction of motion of the body. So we saw that we assumed our body to be going upward here. We assumed our body to be going upward, and that means I have, if I'm to resolve parallel to this plane, I have MA plus FD has to be equal to 420 G sin theta plus the friction force that would be opposing the motion of the body. So that is why I have MA plus FD, and then I also have this. And of course, we know what M is. I know what A is. I have obtained FD. I want AF, the friction force. I know what G is, and I know what the angle is. So in doing all that, I can therefore get what our friction force is. I don't know if that explains your question. Faith. Yes, and then El Nico, you're talking about where this 3,600 comes from. I'm changing the units for the speed from kilometers per hour to meters per second. Those are the SI units, meters per second. And of course, since I'm changing to that, I have, it's like saying 8 kilometers divided by 1 hour. So 1 hour in seconds is 3,600 seconds, and 8 kilometers in meters is 8,000. And that is what I have just done. I hope that's okay, Nico. I hope that's fine because there's no other explanation for that. So I think let's move to the next question. FD is the driving force or the force that causes the motion of the car. And it is acting upwards, or it acts in the direction of motion. So that force that would cause the motion of the car comes from the engine, and it's what we call the driving force. And the power developed or the power generated by the engine is equivalent or is equal to the driving force times the velocity of the car. So that's why we have P is equal to FD times U. And FD is our driving force, or the force that is, causing the upward motion. I think that is it. So let's move to question 4. MA is positive because the body is moving upwards, and that is, and resultant force acts in the direction of motion of the body. Yeah, I think that is it. So let's proceed to question 4, trapezium rule. And yes, I used F is equals to MA, and if you use that, that's the result. That is what you will get here. Oh, okay then. But using F is equals to MA is the same thing as what I have done. Yeah. So let's proceed to the solution of number 4. Yeah, thank you, Raymond. So question 4 says, using trapezium rule with 6 ordinates to estimate that integral of sine squared 2x from 1 to 2 correct to 2 decimal places. So it is important to note that trig functions under calculus you deal with them, or the angles, in radians, or whatever values you have to substitute into the function. It has to be in radians. So it is important you set your calculator in radians. So there are things we want to pick out from the question. It's saying trapezium rule, yes. Then it's saying 6 ordinates. We have to know what an ordinate is. An ordinate is a y coordinate. So it wants 6 ordinates. So if you're going to have 6 ordinates, you have to know the number of intervals that I should have. And with knowing the number of intervals I should have, then I should also know knowing the number of intervals I should have, I should know the number of ordinates, and there's a relationship for that. But we know that H is equal to the difference between the first and last coordinate divided by the number of intervals. And the number of intervals is the number of ordinates minus 1. So I want 6 ordinates, so I have to subtract 1 to give me the intervals. So, and that will give me 1/5, and my interval length is 0.2. And yes, so we shall go ahead to draw our table. So we have x coordinates ranging from 1 to 2. So 1.0, 1.2, 1.4, 1.6, 1.8, and 2.0. And in counting all these, you can see they are 6. And these will give you, and this will help you know that you're on the right track, because these have to be the same number as the audience have asked in question. So we are going to have a column for the first and last value. In other words, 1.0 and 2.0. So in other words, let me call this f of x0 and x5, where this is x0 and this is x5. So we shall input these values in our this function, which is the sine squared of 2x. We shall input this function into our calculator, and make sure your calculator is in radians so that you can be able to solve through. So you have, and in this column, yes, I talked about having values for the first and last, or the last values of x. And then here we have for the the values in between. So there is x1 and going up to x4. So we shall have these in tables. So putting this in the calculator and evaluating, we shall have our first value here 0.8268. And then for 2.0, we shall have 0.5728. Then for 1.2, since 1.2 is in between, we shall put it on this side. So we have 0.44562. And then we shall have as well, for 1.4, we shall have 0.1122. For 1.6, we shall have 0.00341. And this 1.8, we shall have 0.1958. So what we shall do is we shall sum up those in this column, and we shall also sum up those in this column. Summing up here, we have 1.3996, and summing up here, we have 0.76761. So trapezium rule states that this integral 1 to 2 of whatever function you have here is approximately equal to 1/2 of the interval length times the summation of what you get from, let me call this summation f1, and let me call this summation f2. These are not, they are not the standard. F1 and F2 are not the standard, but I want you to get the meaning. So summation F1 would represent the summation of the ordinates of the first value of x and the last value of x. So here, that's why we shall have 1.3996. And here we shall have 2 times 0.76761. Evaluating us is going to give us an approximate value of 2.9. And that is to 2 dp. You could check this with the calculator to ensure that you are correct. Yeah, but these values always carry errors, and do not be surprised if in a question you're asked to find the error made in using the trapezium rule. So that is it for number 4. Is there any question? It looks like there's no question. Let's proceed to number 5. Yes. Number 5. Number 5 talks of, yes, please, Nicholas. You can unmute and ask your question. Or you can ask after I'm done with this question. Let's look at number 5. It says 2 bodies, A and B, of masses 6 kilograms and 2 kilograms, moving along a straight line with velocities 4 and 2, respectively collide head-on. And after a collision, A moves with a velocity of 2.6 in the same direction. How can you press that function in a calculator? You get your calculator. When you get your calculator, I do not know what kind you have, but I shall assume you have FX991. But when you get your calculator, look for sine, or open the brackets, put press sine, then press 2, then alpha, and press X. Then close the bracket, and then put squared. Then you will press calc. There is an option. Oh, you're not allowed to unmute. Okay, let's work on that. Yeah, we are sorry about that. So I don't, yeah, and then when you do that, you press calc and you fill in whatever values of X. Yeah, we have, yeah, you fill in whatever values of X and you can therefore evaluate, but do not forget your calculator has to be in radians. Yeah. I think we shall move on to this question. And we have just checked our settings and you are allowed to unmute. You can actually ask the question. I don't know. Yeah, if that's okay, then let's go to number 5. Number 5 sets two bodies, A and B of masses that, and it's moving along a straight line with those velocities respectively. They are colliding head-on. And after collision, A moves with a velocity of 2.6 in the same direction. So I think let's take note of the language used, colliding head-on, and we should know what this means. This means I have two bodies moving in opposite direction. So I can assume my A is moving to the right. So let me have my body A. This is my body A of mass 6 kilograms, moving at a velocity of 4 meters per second. And then I have my body B of mass 2 kilograms, moving at a velocity of 2 meters per second. So this is before. This is before. Then what happens after? After they are saying A moves in the same direction at a velocity of 2.6 meters per second. And we don't know what is going on with B. So we do not know whether B goes towards the left or towards the right. And that's what we are going to administer when we find out our velocity. So we shall use the momentum equation, that the momentum before has to be equals to the momentum after. In other words, there's momentum conservation. Otherwise, energy is not conserved, and we are going to see that. So the momentum before, and momentum before is equal to the total momentum. I can say total momentum here. Total. Here we can say total as well. So the total momentum, let's say, since we have assumed A to be going to the right, and it's fair to say towards the right is positive. So 6 by 4, that's the momentum for A, plus the momentum for B, that is 2 times -2. It is -2 because of the direction of the velocity. Velocity is a vector quantity, and when you're dealing with momentum, that should be respected. So the total momentum after is 6 by 2.6. This is for body A. And for body B, I do not know what it is, so I'll say 2. Let me say times U. So evaluating this gives us U as 2.2 meters per second. You can help me check that. So having U as 2 meters as 2.2 meters per second means that our body B moves in this direction with a velocity of 2.2 meters per second. Yes, we can now proceed to the loss in kinetic energy. Since there is collision, and I want you to understand the principle of conservation of energy. There is collision, so I expect sound. So the energy, the kinetic energy, or the total energy between A and B, which would have been maintained as kinetic energy, some of it is converted into sound. So that means the kinetic energy has to change. It has to reduce. So that is why there has to be a loss. In other words, you wouldn't have a loss if there was no other energy form of energy produced. But we have a form of energy produced in form of sound. So the kinetic energy has to reduce. So let's calculate the kinetic energy before. And therefore we have a half of 6 times 4 squared plus a half of 2 times 2 squared. That is going to give us 64 joules. That's what happened before. Then the kinetic energy after is going to be a half of 6 times 2.6 plus a half of 2 by 2.2 squared. And that's going to give us 25.12 joules. So that is our kinetic energy after, and clearly we can see there's a drop in the kinetic energy because of the collision. So the loss in kinetic energy is equals to 64 minus 25.12, and that is going to give us that's giving us 38.88 joules as our loss. If there are any questions, please, you can ask any question concerning what we have, this question we have just covered. Okay, looks like there are no questions. I request that we go back to question 3, and we harmonize something. Yeah, yeah. Yes, we are going to harmonize something, and we're going to correct whatever mistake we had done or I had done, and I apologize for that. So I mentioned earlier that the resultant force that acts on a body has to be equals to the summation of all the other forces. In other words, we should have had MA being equal to FD, which is moving upwards, minus F plus 420G sine theta. So we would have had 420 times 1.5 being equal to 225 minus F minus 420 times 9.8 sine of 0.7162 degrees. So I think that gives us a value of F, which I expect which will be different from what we had at first. So we have 420 times 1.5 minus 225, then plus 420 times 9.8 times sine of 0.7162, and gives us F as 456. 456.4 It was 456.449 newtons as our friction force. So we had made the correct assumption that it's going up, and therefore our friction is positive, showing that it's acting in the opposite direction than the one we had assumed for motion. So from the questions presented, if there are any questions that have developed, please ask. Or if everything is okay, you can let me know.
It's okay.
All right. Thank you.
I'd
So,
like to ask.
yes,
I have
please.
a que-
Yes,
Okay.
hi. Have
I
you
beg your
used
pardon?
FMA?
Yes, I've used F is equals to MA. It is implied here. Here. Yeah, here it's implied in the first step. Is that okay?
Yes, thank you.
Yeah. Then you've had a question.
Yes, I'd like to ask, could you please re-explain the correction? Okay, the force is equal to that part, the first step.
What we had done here.
Yes.
Okay. We assumed. Yes, I'll come to that. We assumed that our body was going up, So, or up the plane. So if it's going up the plane, then every force that is, Marvin, I request you first mute. Then every force that is pointing towards a direction is positive. And from our analysis or from whatever we got here, oh yes, friction is negative, sorry. Yeah. So we got that FD is pointing upwards, and then the component of the weight, this one, is pointing downwards. The force, the friction is pointing downwards. And the only thing that's pointing upwards is FD. So, and we know from our definition of resultant force, it says that we cater for the directions and the magnitude of the forces. So the total of all those forces, including the directions, has to be equal to the resultant force. So we assumed upward motion, so we can say that FD is positive. So we can, MA is giving you the resultant force, but again, the resultant force F can be defined as the, the algebraic sum of all the forces that are acting on the body. So F can be expressed as FD minus 420 G sine theta plus F. In other words, FD minus all the forces that are acting downwards have to give you MA. So that is how I developed that expression. I don't know if that's okay with it.
Yes, it is.
Okay. Yeah, and yes, sorry about that, but our friction is negative. Yeah, I had forgot to change the sign. Yeah, because F was on the other side. Otherwise, the friction force is negative. So that would mean something else, that our body should have been going downwards. So let me write it here, body should have moved down the plane. Yeah, I think that is it. I hope that is okay now. Yeah, okay. With that, I would love to invite the next presenter. Yes, Melissa, you had a question.
Yes. On number 5,
Yeah.
I don't know if my computation that's wrong,
Mm.
but my energy before is not 64, it's 50.
Your kinetic energy before is what?
52 joules.
52.
Yes.
Okay. It's 52, then you can just make that correction, 52. And we shall have 52 over here. And that changes our answer. Twenty-six point 26.88. Yes, I think that's okay now. Then James.
All right. So back to the question of a plane. So for the
the-
expression of
Which question? Number 4.
yes, please.
Number 4, number 3.
Yeah, I think one of the plane, one of the plane we're doing must be number 3 then. All right. So okay, with the correction you have made,
Yeah.
doesn't it already imply that the friction is negative from the first expression? So do we really have to add a negative to the final answer? The mere fact
Yes.
that we stated MA equals to FD minus, into brackets, F plus 420 G sine theta.
Okay.
Do we
As
have
I
to
say,
add the negative on the final answer?
yes, we do, because friction is a force and it's a vector quantity, and its direction has to be catered for. In our assumption from the very start, we assumed our body to be moving upwards, and therefore our friction will be pointing downwards. So if we got our value of F as positive, as a positive value, then that would have meant that the body is moving upwards, yes, and the friction is pointing this downwards. It's opposing that upward motion. But when we did the calculations, we got our frictional force as a negative value. That means that the friction is acting in the opposite direction. In other words, friction is acting up towards up the plane, and therefore this body should have been moving downwards. So we have to put that negative there to cater for that. I don't know if that's okay.
All right, thank you.
Kale. So I'll invite the next presenter of question 6.
All right, we shall move to our next question, which is question 6. And it came from statistics and probability. Yes, so the question reads, the probability that Bob wins a tennis game is 2/3. When he plays 8 games, what is the probability that he wins at least 7 games, then exactly 5 games? Yeah, so before you attempt such questions, you have to identify which kind of distribution you are dealing with. Is it binomial? Is it continuous? Rectangular? Or is it just probability theory? Yeah, so in this question, we have someone playing a game. That in a game, you have 2 options. You either win or lose. Yeah, so the person played 8 games. So that rules out. Okay, this means that we're dealing with binomial distribution, because you have either a win or a loss. Then yeah, the event has been repeated for a number of times which is less than 20. So it's not normal approximation to the binomial, but it's just the binomial distribution. Yes, so we have to determine our P, which is the probability of winning, and our Q, probability of losing. As you could have a draw. I know I have draws in tennis games, but yeah, we're just looking at the winning and losing the events, either win or a loss. Yeah. So the probability that he wins is 2 out of 3. So that's our P. Which means that our Q will be equal to 1 minus 2/3. Probability that he does not win, 1 minus 2/3, which gives us a third. And then N, the number of times for which he played, is equal to 8. Yes. Then part A wanted us to find the probability that he wins at least 7 games. So we have to be acquainted with these words, at least. At least means that you've won 7 games and above. So it means that a 7 is included. So it means that probability of X being greater than or equal to 7, so that's at least 7 games, will be equal to the probability that X is equal to 7 plus the probability that X is equal to 8. Yes, now that for binomial distributions, the probability of X is equal to R is got by taking N combination R times P power R times Q power N minus R. Yeah, of course, some values can be got directly from the logbook, but in this case, our P is equal to 2/3. 2/3 is not in the logbook, so I'll just have to use the formula. So when our R is equal to 7 and our N is equal to 8, we shall have probability of X is equal to 7 as 8 combination 7 times our P, which is 2/3, power our R, which is 7, times a third power N minus R. So 8 minus 7, which gives us 1. Then for X is equal to 8, we shall have 8 combination 8 times P 2/3 power 8 times a third power 0. 8 minus 8 gives us 0. Yes. So now a mistake people usually make here is to compute this whole thing at once in the calculator. They just add up everything and put in the calculator. You usually miss out 1 mark. You have to show these, you have to show how you got this entire probability first and added it to this one. Must be very clear. So you first of all compute this, then you also compute this into your calculator. So the first bit of it will give us 1024 out of 6561. Then probability of X is equal to 8. Shall get 1280 out of 6561. So each step must be shown. Then from there, once we simplify, we shall get, sorry, this one give us 256. Then on simplifying, we shall have our answers 1280 out of 6561. You can leave it in that form, or you can write it to 4 decimal places. You can write it as a decimal fraction, but round it off to 4 decimal places. Yes. Then Roman 2 wanted us to find. Is someone having a question? I think someone is unmuted. Okay. Part B wanted us to find the probability that he wins exactly 5 games. So probability of X is equal to 5. We shall just use our formula for binomial distributions. We shall have 8 combination 5 times 2/3 times 2/3 power 5 times a third power 8 minus 5, which is equal to 3. So that gives us our answer as 1792 out of 6,561. Yes. So if these distributions were more than 20 or equal to 20, we would have used normal approximation to the binomial theorem. But since they are just 8, we use the binomial. It's a binomial distribution, so that's how we go about it. Yeah, it was our question 6. I hope we don't have any questions there. Yeah, I hope that was clear to everyone. If there's no questions, I'll invite our next. I'll have it take us to our next question.
Yes, question. Thank you, Brian, for your presentation. We shall move to question number 7. It says a city A is 600 kilometers from city B, and a pilot sets off from A in an aeroplane traveling at 250 kilometers per hour on a bearing of south 60 degrees east, and the wind blows at a bearing of 240 degrees at the speed of 80 kilometers per hour. Find the time it takes for the pilot to travel to city B. Yeah, as we do this question, please, you can check in the chat. There's a link to a feedback form that has been sent there. Kindly, you can spare off some time, like can even be like a minute or two, and you fill in that form. Yes, and it will be shared as well in the WhatsApp groups. So for those who have attended, I request that you fill in the form. So our question here. So it's important to understand that this pilot wants to go from A to B, but then there is an aspect of wind. And of course, if he sets off directly from A to B, then the wind may drift him from his course. So he has to set off in a certain direction so that with the effect of the wind, he is not pulled away, or the wind just pushes him closer to his destination. So that's why our diagram will indicate that yes, the city B is not directly on the bearing as explained in the question here. The question says south 60 degrees east. Yes, the city B is not directly on this bearing, but this is the direction he sets off towards. So he sets off towards the direction in order to beat the wind, such that the wind, yes, though it will have the effect on a plane, the wind will just drive him back towards the city B. So in our sketch, we shall have this. And by the way, before we continue, it's important to also note what this bearing is. All the bearings are measured from the north to north clockwise, unless indicated as here in the question. But if it's just an angle, it's measured from the north. So we shall have a sketch. Our sketch will look like this. Let me say this is city A. Our city A is here, and the question says he sets off south 60 degrees east. So I'm going to measure 60 degrees from the south towards the east, and I'll have something like this. So this is 60 degrees, and here they have said he's moving at a velocity of 250 kilometers per hour. So he sets off in a certain direction, but then from there is wind. Let me say at this point, let me say there is wind and its effect starts from there and it acts 240 degrees. 240 degrees, and that is clockwise. So I measure 240 degrees clockwise and I draw that. So yes, the wind is affecting him, but he has to reach point B, and let this be our city B. So I have city A, city B, wind is blowing in this direction at a speed or at a velocity of 80 kilometers. At 80 kilometers per hour. So yeah, we have our sketch. So we shall just employ some trigonometry and we are going to use a triangle. In other words, I'm going to draw a line connecting city A to city B. And remember, we have been given the length or the distance between the two cities as 60 kilometers. So this entire angle is 240 degrees. If this is 60 degrees, this gives me 60 degrees. And therefore, this would also have to be 60 degrees. So I'm going to use the cosine rule and solve this. So we have a triangle. Let me just draw it here. This is 60. This is as well 60 degrees. And I do not know the velocity, the actual velocity, which he would have taken from A to B. So let me call it V. And I know the velocity he took to move from here to a certain point. Let me call it C. It was 250 kilometers per hour. And here the wind blew at a speed of 80 kilometers per hour. Therefore, I'll use the cosine rule. And since I don't know what, the only thing I do not know is V, I'll make V the subject, and it is convenient to say V squared is equals to 250 squared plus 80 squared minus 2 times 250 times 80, giving us times the cos of 60 degrees. And evaluating this gives us V as 221.133 kilometers per hour. You could help me check that. So since I know the velocity he would have taken to move from A to B, and I know the actual distance between A and B, then I'll use from the expression distance being equal to speed times time. I will have 600 is equals to 221.133 times the time t. So they're asking for the time it takes the pilot to travel to city B. So it would be 600 divided by that, and that would give us 2.71 hours, which are approximately 2 hours and 43 minutes. Yeah, and with that, we have done number 7. Is there any question? Yes, please, Melissa.
Okay, I just want to clarify. The bearing given to us in the question is the direction taken by the aeroplane and not the direction of city B from city A.
Yes. That is exactly it. Yeah, it is. I hope that is clear. Then, if there are no other questions, then I'll invite the next presenter.
I have a question.
Yeah, yes, Paula.
The distance given to us, the 600 kilometers, I thought it's a distance from A to B, but okay, you've considered it as from A to B after the wind had blown. I'm getting confused.
Okay, Okay, let's look at the question critically. The question starts by saying a city A is 600 kilometers from city B. Then there's a comma. That's one of the statements. Then the question goes ahead to say a pilot sets off from A in an aeroplane traveling at that speed on a bearing of that towards city B. In other words, he's going towards city B, but this is how he sets off. He sets off from at a bearing of south 60 degrees east. So, but he's heading towards B. That's what the statement means. Then the next statement talks about wind blowing at that bearing at that speed. So in other words, there would be there's a point where the wind is going to affect him. And okay, this diagram or this sketch that we have is trying to idealize or to create or to imagine what would have happened, trying to simplify the situation. Because if you think about it, a plane is moving in the air and there is wind acting on it, it will not directly, divert like at this point here. It will not move from A for a certain distance and then divert directly because of wind. No. The idea is the wind affects it at some point in time, and the wind is going to change its course. So if this pilot sets off from A to B directly, then we shouldn't forget that there is wind that will affect his course and would make him divert away from city B. In other words, he's looking for the shortest way of getting to B without with the wind there. So how will he make use of the wind to help him get to city B? So he has to set off against the wind so that the wind will affect him and push him towards city B. So you're going to find other questions that ask what is the shortest distance. Shortest distance, of course, would be this one from A to B, but then he can't take that shortest distance because of the wind. The wind will push him away from city B. So the question has been dissected into 3 statements, and each of them has their own meaning. So in being able to interpret that is when we're able to develop this sketch. I don't know if that explains your question or your query or goes beyond.
Yes, it does. Thank you.
Kale, you are very, very welcome. So at this very time, I would like to invite the presenter for question 8.
Yes, back to question 8, which was also from probability, particularly probability theory. And it reads 2 events, M and N, are such that probability of M is equal to 0.7. Probability of M intersection N is equal to 0.45. And probability of M complement intersection N complement is equal to 0.8. And part A, they want us to find the probability of N complement. Yeah, now for probability theory, in case you have 2 probabilities, you can look at them as sets. So N complement means they want everything outside set N. If I had maybe 2 sets, where this is our M, this is our N. So N complement means they want the region outside set M. What does it mean? It means that if we are to get that region, we shall first of all consider M only, which is M intersection N complement, and then everything outside, which is M complement intersection N complement, or that can also be written as M union N, but complement. Yes, so it means that for part A, we shall have probability of N complement being equal to probability of M intersection N complement plus probability of M complement intersection N complement. The contingency table can also come in handy. Yes, in case you can't use these sets. But in the question where I don't see M intersection N complement, so it means we shall have to first get it. So, but probability of M intersection N complement, it means that we shall get probability of M minus the intersection probability of M intersection N. So our M was 0.7, our intersection is 0.45. And I subtract, I get 0.25, which is our probability of M only, or M intersection N complement. Yes, I was given probability of M complement intersection N complement. So I'll go ahead and get my probability of N complement. So probability of N complement will be equal to 0.25 plus probability of M complement intersection N complement, which is 0.18. When I add up those two, I get 0.43 as my probability of N complement. N complement. Then part B wanted me to get the probability of M or N, but not both M and N. So probability of M or N, but not both. Sometimes it can be written, can be given to you like that. M or N, but not both. Yeah, so that region is actually probability of M intersection N complement plus probability of M complement intersection N. Yeah, because you're just looking at M only or N only in simple terms. Just a simple explanation I can give. If I can represent it as a set, M and N. I want M or N, but not both occurring. So they're just excluding the intersection from the union of these two. In other words, the other formula you can use is probability of M union N minus probability of M intersection N. Yeah, that's the other formula I can use. Yeah, so probability of M intersection N complement, we got it as 0.25. Then probability of M complement intersection N, which is actually probability of N only. Yeah, it means that first of all, you have to have probability of, it's the same as probability of N minus the intersection, which is probability of M intersection N. Yeah, so probability of N, we have N complement, so I can get it as 1 minus 0.43, then minus our intersection, which was 0.45. So 1 minus 0.43 gives us 0.57, I hope, minus 0.45. We get that value as 7 minus 5 is 2. I'm getting 0.12. I hope that's what you guys are also getting. So our final answer will be the sum of these two. This value here and that value there. So you have probability of M or N, but not both, being equal to 0.25 plus 0.12. This gives us 0.37 as our probability. Yes. Or as I've told you, you could have used probability of M union N minus probability of I just subtract the intersection from the union minus probability of M intersection N. If you solve that, you get, if you expand this, substitute for M union N, which can also be got from these values that were given, because they gave us probability of probability of M complement intersection N complement as they gave it to us as 0.18. But remember, this probability can also be written as probability of M union N but complement. The complement moves out of the brackets and the intersection changes to union. De Morgan's rules in probability, which is well explained in a probability playlist, I think in lesson 2. Yes, so if you have probability of M union complement as 0.18, it means that probability of M union N is equal to 1 minus probability of M union N but complement. So we shall have 1 minus 0.18. Therefore, we shall have it as 0.82 as a probability of M union N. And therefore, the probability that they wanted from us, probability of M or N, but not both, will be equal to 0.82 minus the intersection, which was 0.45, which still gives us 0.37 as a probability of M or N, but not both occurring. Yeah, so I hope that's clear. Anyone with a question? Or further still, the probability has very many methods. The probability of the union could have been got from taking probability of M, probability of M plus probability of N minus probability of M intersection N, just this one. Yeah, but I think the question is clear to everyone. Don't see any hands raised, so that's all for that question.
Okay, so we've come to the end of the seminar. We're not going to go through section Bs because of time. That will take a lot of time. Yeah, but thank you all for attending. We can, have further discussions of the section Bs in the WhatsApp group. We have, or we can look at, sending our solutions. But yeah, thank you all for attending. I hope it has been beneficial to you. There's a feedback form, a link to a feedback form that's in the chat. So please be sure to fill it out. Nicholas, is there anything you want to say?
I just want to thank you, teacher. Thank
You're
you
welcome.
for your time. Yeah.
You're welcome. You're welcome. Thank you. Thank you for appreciating.
Jonathan,
Yes.
Yes,
Yes, Brian.
someone had asked why I didn't include, if I can share my screen briefly. Someone asked why I didn't include what? Why I didn't include the outside of these two sets for part B. Now the condition is M or N has to occur, but both must not occur at the same time, must not occur at the same time. So if I put the outside of this set, it means that okay, for that, if I include that outside, it means that I've nullified my condition, as I said in the chat, because outside means that neither is occurring, yet they want M or N occurring. I hope that's clear.
Yeah. I think they also call that XOR, where you only take one but not both. Yeah. Yeah. So thank you all for attending. Yeah, let me just put the MATLAB number in the chat. Yeah, let me just put the MATLAB number in the chat.
I'd like to ask,
Yes, Yvette?
I'd like to ask, how can we access the recording, the recording of the meeting?
Oh yeah, so the recording is going to be uploaded to the YouTube channel. Yeah,
Oh, okay.
and you'll be sent the link, don't worry.
All right. Thank you so much.
Yeah, so the WhatsApp number has been sent. The WhatsApp number has been sent in the chat. Feel free to reach us out on that number. See what we can do for you. Have a nice weekend, everyone. Fill the form, fill the form, fill the form. And the form. Let's fill the form. Let's not forget to fill the form.